When we make things in a factory, when we make things like pancakes or cookies, do we always make exactly the right number? No. You're making pancakes and you're trying to get fancy and flip them, and you flip one on the floor, right? Well, that one's gone. You get distracted by a phone call and the next two get burned, right? And so those are gone. So in theory, maybe you could have made 25 pancakes, but you really only made 22 because stuff happened, right? Bicycle factory, maybe one of the wheels got bent because someone tripped and fell on it, or who knows. Stuff happens, right? Stuff happens in chemical reactions too. There's all sorts of reasons why you don't get what you think you might get. So we talk about different types of yield. The theoretical yield, theoretical is in theory, this is what you calculate. If everything works perfectly, this is the most you could get, right? Theoretical. What we have been calculating is the theoretical yield. The actual yield is the amount you actually get. If you do the experiment and measure the amount of product, it's not going to be the same as what you calculated for a variety of reasons. So what is a useful measure of how well you did is something called percent yield. And this is still following the pattern of percent being part over whole times 100. It's the actual yield divided by the theoretical yield times 100%. So the units on the yield, whatever, if they're liters or grams, they end up canceling out, and the unit on this is percent. Now, the percent yield should be less than 100%, or exactly 100%, right? Because if you have enough ingredients to make, or enough stuff to make 25 bicycles, and you come up with 26 bicycles, how does that work? Right? That's just not possible. Now, it could happen with pancakes, though, couldn't it? Because what if you made them all a little too small? You're going to get more of them, but they're not the right size. When you get a yield, a percent yield in a chemical reaction that's greater than 100%, it does not mean that you created mass. It means that you screwed up. If your reaction is giving a precipitate, and that's in the solution, and then you filter it out and you dry it and you weigh it, several things can happen. The most common thing is students are impatient and they don't let it dry completely. So then when they weigh their product, it's wet. And it weighs more, it appears to weigh more than is actually there. And so that's a very common reason for getting a yield over 100%. But a yield over 100% means that something went wrong. So here's an example. A student dissolve. Oh, good grief. A student dissolves. Singular noun. Good grief. Okay. A student dissolves 1.00 grams of cadmium 2 chloride in water and adds sodium sulfide to obtain a precipitate of cadmium 2 sulfide. The precipitate weighs 0.775 grams. How do we know that it weighs that? The student did it, right? And weighed it. Is this a theoretical yield or an actual yield? It's an actual yield. You kind of have to use the words and infer that. It didn't come out and say it explicitly. But here we're talking about a student doing an actual experiment, and the precipitate weighs this. He weighed it. That is the actual yield. Here's the chemical equation. Using stoichiometry, we calculate the theoretical yield to be 0.788 grams. So even if it didn't say theoretical, The fact that we calculate this tells us this is the theoretical yield. The question says, what's the percent yield? We take the actual, divide by the theoretical, and multiply by 100. So 0.775 grams divided by 0.788 grams times 100%. See what happens to the units? They go poof. 0.775 divided by 0.788 times 100. 3 sig figs, 98.4%. That's really good. That's a really good yield. Any questions? Be careful with numbers, especially when you get things like this. I had 2 students in my 1B class just this week doing very complicated calculations, and they transposed 2 digits. And so they're doing everything right, but they wrote down the wrong number, and then the answer isn't right, and they're like tearing their hair out. Check your numbers. It'll save your hair. Here's another example. Ammonium nitrate is used in explosives and is produced by the reaction of ammonia and nitric acid. Here's the equation for that. If 15 kilograms of ammonia gives an actual yield of 65.3 kilograms of ammonium nitrate, what is the percent yield? The calculated yield of ammonium nitrate for the experiment is 70.5 kilograms. Now, they were really nice in adding that last sentence, because otherwise we'd have to do the stoichiometry and figure it out. So, do we need this 15 kilograms of ammonia? No, because they did that calculation for us. If this wasn't given to us, we'd have to take this kilograms of ammonia, convert it to grams, convert it to moles of ammonia, to moles of the ammonium nitrate, and grams of the ammonium nitrate. And you can do that if you want to. You'll come up with 70.5 kilograms. So the 70.5, is that the actual or the theoretical? This is theoretical. I often call him Theo. And then what's this number? That's the actual yield. So in this problem, they gave you both of them. But sometimes you'll have to calculate the theoretical yield. They have to give you the actual yield. Because we're not doing experiments in this class, right? Yeah. So there's no way you would know what it is. So actual over theoretical is what percent yield is. So 65.3 kilograms divided by 70.5 kilograms times 100%. The units do need to cancel out. 65.3 divided by 70.5 times 100. 92.6%. Again, really nice yield. Any questions? This is a practical sort of calculation, because if you're running a chemical factory or something and you need to turn out a certain number of kilograms of this fertilizer or explosive or anything, there are legitimate businesses that create explosives. There are. I know it sounds funny though. You want to make a certain amount, you need to know how much starting material to begin with, because it's not going to be 100%. It never is. And so if you figure out what your percent yield is, then you can plan for the stuff that doesn't react. It's like if you know that you're a klutz and you're always dropping pancakes, or you're distractible and you're burning pancakes, you're not going to make just exactly the right number for your company. You're going to make some extras because you're going to screw up, and you know that. Ta-da! End of chapter.